Hello everyone. Today we'll quickly review the key concepts of relations and functions in just 5 minutes. Let's get started. A relation is a set of ordered pairs from two sets. For example, if we have a set A and a set B, a relation R is a subset of A crossed B. There are three types of relations. Reflexive, where every element relates to itself. Example, relation R where ordered pair I, I satisfies A is less than or equal to I. Symmetric, if A is related to B, then B is related to A. Example, relation R where X and Y live in the same locality. Transitive, if A is related to B and B is related to C, then A is related to C. Example, let T be the set of all triangles in a plane, relation R, where T1 is congruent to T2. If the relation is reflexive, symmetric and transitive, then it is called an equivalence relation. Let's solve an example problem. Show that the relation R in the set R of real numbers defined as R equal to A, B, where A is less than or equal to B square, is neither reflexive nor symmetric nor transitive. For the relation to be reflexive, for all A belongs to R, A should be less than or equal to A square. This condition is true for natural numbers but not for real numbers. For instance, if we take a fraction, let's say 1 by 2, then 1 by 2 is not less than 1 by 2 square. Hence we can say relation R is not reflexive. For the relation to be symmetric, if A, B belongs to R, then B, A should belong to R. Let's say if A is equal to 1 and B is equal to 2, then 1 is less than or equal to 2 square, but 2 is not less than or equal to 1 square. Hence we can say relation R is not symmetric. For the relation to be transitive, if A, B belongs to R and B, C belongs to R, then A, C should belong to R. Let's say if A is equal to 1, B is equal to -2 and C is equal to -1, then 1 is less than or equal to -2 square, and -2 is less than or equal to -1 square, but 2 is not less than or equal to -1 square. Hence we can say relation R is not transitive. A function is a special type of relation where elements in the domain are associated with elements in the codomain. Here, X is the domain and Y is the codomain. The set of all outputs is called the range or image. There are three types of functions: one-to-one or injective function. Here, every element in domain has a unique image, which means A is pointing to unique B, and we won't have two or more A pointing to the same B, but we can have a B without a matching A. On to function. Every element in the codomain is an image of at least one element from the domain, which means that every B has at least one matching A, and there won't be a B left out. Bijective function. When a function is both one-to-one and onto, this means every A has a unique B and there is no B left out. Let's solve an example problem. State whether the function f for real numbers defined by f of x is equal to 3 minus 4x is 1, 1. Onto or bijective. To check for one-to-one function, we have f of x1 equal to f of x2. Substituting f of x and solving for x, we have x1 equal to x2. Therefore, f is one-to-one for all real numbers. To check for onto function, let e be equal to f of x. Substituting f of x and solving for x, we have x equal to 3 minus y divided by 4. Now substituting x in f of x, we have y equal to y. So for every given y in R, there exists x in R. Therefore, f is onto for all real numbers, and as the function f is both 1 to 1 and onto, it is bijective function. Here's a quick recap of the video. A relation is a set of ordered pairs from two sets. There are three types of relations: reflexive, symmetric, and transitive. A function is a special type of relation where elements in the domain are associated with elements in the codomain. There are three types of functions: 1, onto, and bijective function. Okay, so that's it for today. Read the description for more details. If you find the video useful, like, share, and subscribe.